All right, geometry. I'm in a good mood. Okay, we're gonna do some simplifying radicals first, and then we're going to find all six trig ratios by using the Pythagorean theorem. I want to do today and tomorrow with this topic, and then I'll assign a test over the weekend, and it'll be due on Monday. So let's get rolling. So let's get. These are the five simplify the radicals problems. If you want to do these independently, go for it. Pause the video. Okay. All right, so let's start off with something easy. Let's go with the square root of 90. I'm in a good mood. I got some orange soda, so. Anyway, so let's say I want to break down the square root of 90. Well, I could break this down into radical 9, radical 10. Well, there's two ways I can look at this. Do you want to just pull out square root of 9 is 3, or do you want to do radical 3, and circle out the pair of twins? Either way is cool to me. What I like to do is, if I see a perfect square, I'm going to take advantage of it. So I like to break this down and say that's a 3. Square root of 9 is 3. And while I'm at it, well, square root of 10, I can't exactly, I don't think it's a perfect square, so let's just try radical 2, radical 5. So there's nothing else I can do to break it down, so the final answer is, if I've got the square root of 90, I can rewrite the problem as 3 radical 10. Okay? The other way I could do it is radical 3, radical 3. The other way, you're still going to get 3 radical 10. Okay, square root of 153. Well, that's a tough one. Well, when in doubt, is it odd or even? Well, it's odd, so I can't divide by 2. Well, go back to my pre-algebra skills. If it adds to a multiple of 3, then it's probably divisible by 3. 1 plus 5 is 6. 6 plus 3 is 9. So yeah, that's your little trick. So anyway, let's just try 153 divided by 3. And I'm going to get 51. Okay, so I've got radical 3, radical 51. Well, I can't break down radical 3 anymore, but what I can do is break up radical 51. I believe I can break that down again by radical 3 times, I think it's 17, but I'm going to make sure in the calculator. 51 divided by 3 is 17. So I've got radical 3 times radical 3 times radical 17. 17 is a prime number, 3 is a prime number, 3 is a prime number. However, I'm going to circle out a pair of twins because those are going to become 3. And 17 can't be broken down even more, so that's going to be 3 radical 17. Okay. Let's move on to problem number 3. Can I simplify radical 80? Well, what can you do? Well, I've got 2 times 40, 4 times 20, 8 times 10. Why don't I go with radical 4, radical 20, because at least I know I got a square there. Well, I'm going to pull out this 2, because the square root of 4 is 2, but can I break down radical 20? So I've got 2 radical 4 times radical 5. Hey, hey, square root of 4. Even though I could break this up into radical 2, I've got a 2 here. So this becomes 2 times 2. And I can't break down radical 5, so in the end, this becomes 4 radical 5. Radical 80 is equal to 4 radical 5. Sorry about the confusion. I thought I was going to take less space, but maybe it's because I have all the green parts. Anyway, square root of 672. Well, as the bigger numbers they get, let's try to take out a big number if we can. So when in doubt, I go with my 2's, and if I can take out a bigger number than 2, so be it. So 672 divided by 2 is 336. Let's see if I can divide by 2 again. And I can. Can I divide by 2 again? Whew, I can divide by 8. Okay, all right. Let's go for the big home run here. So radical 8 times radical 80. Oh, you know what? Why did I stop? Let me divide by 2. See if I can divide by 16. I can't. Oh my god, I can. Radical 16. Can I divide by 32? Oh my god. This is a big one. Alright, so let's see how I work this out. Wow. So, let's just play that little game. That move just dawned on me. So I was going to do divide by 2, divide by 2, divide by 2. No, dude. Let's go for some home runs. So what was it again? We just divide by 2, divide by 2, divide by 2. I believe that was dividing by 32. So 672 divided by 32. That was 21. So radical 32, radical 21. Yeah, let's go for the ones in the middle. Genuinely proud of myself. That was awesome. Anyway, let's break down the square root of 32. Well, I know that a perfect square can be taken out. I'm going to take out radical 16, radical 2, and I'm going to break up radical 7 times radical 3 here. Well, I know that I can break up radical 16 into 8 times 2 or 4 times 4, but you know what? It is a perfect square. So why not just pull out the 4 right here? Can I take something out of 2, 7, and 3? No, they're all prime. So the 4 is the coefficient that I factor out. 2 times 7 is 14. 14 times 3 is 42. So unfortunately, the final simplified form of square root of 672 is 4 radical 42. Okay. Last one of the simplified one, then we'll do some triangles. Square root of 450. Well, it ends in a 0. I'm going to take out a 10. 10 and 45. Let's see what else I can do here. Radical 2, radical 5. Can I break down 45? Yeah, let's go with 3 times 15. I was going to do 9 times 5, but I wanted to break the norm. Can I break this down even more? Yeah, radical 2, radical 5, radical 3, and this 15 can be broken up into radical 5, radical 3. Oh, I see where this is going. Look at that. And you know what you can do? You can reorder it if you'd like. That's what my high school teacher used to make us do, is reorder it. I can factor out the 3's. I can factor out the 5's. So this whole thing becomes 3 times 5 times radical 2. Or 15 radical 2, because the 3 and the 5 factor out. Okay. All right, let's do some triangles now. Okay. The goal is to look at angle theta and find all 6 trig ratios. So step 1, you might want to solve for the unknown side first. Well, what do I know about 20 and 10? They're legs. Okay, they are legs. We don't know the hypotenuse, so let's call it x for now. So, by the Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. So 10 squared plus 20 squared equals x squared, right? 100 plus 400 equals x squared. 500 equals x squared. Sorry about And I'm going to square root both sides. Well, now that I've got x equals the square root of 500, can I break down 500? Sorry, the square root of 500. Yeah, let's start with the obvious one. Let's go with radical 50 times radical 10. Okay, I'm going to go with radical 5 times radical 10. Oh, you know what? Little secret. I'm not going to break down that 10 because I know that we've got perfect match that we can factor out. That's going to be 10. So x, and I can't break down the radical 5, so x becomes 10 radical 5. But that's not what the directions are asking for, but at least now I know that I can rewrite the triangle that looks like this. So I've got a right triangle, 10, 20, and the hypotenuse is 10 radical 5. And my theta is right there. All right. See if you guys can do sine, cosine, and tangent for angle theta, cosecant, secant, and cotangent for angle theta. Pause the video. Okay, now I'm going to do the problem. Okay, so now the sine of angle theta, I'm going to take up some space. The sine of angle theta would be the opposite over the hypotenuse. 10 over 10 radical 5. If you want to show off and simplify this fraction, I mean, if you want to leave it like this, I'm not going to be mad. I promise you, I'm not going to be mad. But if you really want to show off, you can reduce this fraction. 10 divided by 10 cancels out to form 1 over 1, so that's going to be 1 over radical 5, but I'm not going to be upset either way. I'm not going to be upset. How can I get upset with you? We've got the cosine of angle theta, which is the adjacent side to its hypotenuse, which is 20 over 10 radical 5. If you want to leave it like this, I'm not going to get mad at you. But if you want to show off, 20 divided by 10 is going to be 2, so the cosine of angle theta is 2 over radical 5. But once again, no pressure to simplify the fraction. All right, the tangent now. The tangent of angle theta would be the opposite side over its adjacent side. That'd be 10 over 20. But if you really wanted to show off, you can simplify 10 over 20 into 1/2. So therefore, we've got the cosecant of angle theta, the secant of angle theta, and the cotangent of angle theta. And those are the reciprocals. So if your answer was over not simplified, how would I flip each individual ratio? Okay, so the cosecant of angle theta would be 10 radical 5 over 10. The secant of angle theta would be 10 radical 5 over 20. And the cotangent would be 20 over 10. Either way, here are your reciprocal trig. So if we've got 10 radical 5 over 10, the 10s can cancel out, leaving me with radical 5 over 1. Or just radical 5. 10 radical 5 over 20. Remember that 2 radical 5 is a simplified form. So this would be radical 5 over 2. And finally, the cotangent of theta is a reciprocal of 1/2 or 2. I'm not going to get mad no matter how you write it. If you leave it unsimplified, I'm going to be okay. If you leave it simplified, cool. I just care that you know what the directions are. Alrighty? All right, number 2. Same thing. In this case, well, what do we know? Well, I've got a hypotenuse and I've got a leg. I don't know this, so I'm going to call it x. So x squared plus 15 squared equals 25 squared. I believe 15 squared is 225. Yes, it is. And I believe 25 squared is 625. I'm just making sure with the calculator. 625. So now, subtract both sides by 225. So that gets me x squared equals 400. I'm going to square root both sides. So that gets me x equals the square root of 400. Now I'm going to simplify this radical, make life easy for me. Well, what could I break radical 400 into? There's a variety of choices. You could do 2 and 200, 4 and 100. Ooh! Radical 4. Radical 100. Oh, this is pretty. I should have known. I should have seen this right off the bat. Square root of 400 is in fact a perfect square because it is, well, let's find out. The square root of 4 is 2, and the square root of 100 is 10. So x is equal to 2 times 10, or 20, which makes total sense because the square root of 400 is 20. 20 times 20 is 400. Oh, it's so obvious. Ah, Matt, you're so silly. You're so silly. I was such a nice guy for this. I thought I was just clever. I just picked two random numbers where the digit was 5 at the end. But you know what, Matt? You're just too nice. You're just, oh, man. So anyway, the point is now our triangle looks like this. I'm in a good mood. I'm drinking orange soda. And I guess if you guys give me orange soda, I'm going to give you easy problems on the test. No, that's not how it works. Anyway, so I'm just going to redraw the triangle with information that I like. 15, 20, and 25. And remember that our angle theta is in the corner. So if I look at this angle theta, let's do sine, cosine, and tangent. Sine of theta, cosine of theta, tangent of theta, and then the cosecant, secant, and cotangent. See if you can do all these independently. Okay, so the sine of theta is the opposite over its hypotenuse. That'd be 20 over 25. The cosine of angle theta would be 15 over 25. And the tangent of angle theta would be 20 over 15. And again, you can simplify these fractions if you want. Be my guest. You don't have to, though. Cosecant. So then the cosecant would be the reciprocal of sine, which would be 25 over 20. The secant would be the reciprocal of cosine, which would be 25 over 15. And the cotangent of angle theta would be 15 over 20. Now remember, you can always, you can leave them like this if you'd like. I'm not going to get mad. But if you want to simplify this, you can make this 4/5, 3/5, and 4/3. And your reciprocals will be as follows. 4/5 becomes 5/4. 3/5 becomes 5/3. And 15/20 can become 3/4. It's the same thing. But if you want to leave it with the 20, 25, and 15, no preference. Your call. All right. All right, let's say we do one more and then we'll call it a day. All right, angle theta, I've got x. See if you can do this problem independently. Okay, x squared plus 8 squared equals 18 squared. I apologize, folks. I don't know my 18 times tables. Shame on me. 18 squared, sorry about that, is 324. And then I'm going to subtract 64 from both sides. So x squared, 324 minus Nintendo 64 is going to be 260. Okay? Square root both sides. And I've got x is equal to the square root of 260, whatever it may be. Well, I'm low on ideas. Well, but it ends in a 0, so I'm going to break this up into radical 10, radical 26. Anything helpful? Well, 10 can be broken up into radical 5, radical 2. And radical 26 can be broken down into radical 2, radical 13. Prime, 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 prime. But we got ourselves some twins. So in the end, this becomes 2, radical 5, radical 13. Once again, I can't really do anything right there, so unfortunately, 5 times 13. I think it's 65, but I'm just making sure. 65. So the whole thing is literally just going to be 2 radical 65. But that's not what the directions are asking for. The directions are find me the 6 trig ratios once I simplify the radical. So the sine of theta, cosine of theta, and the tangent of theta, the cosecant of theta, the secant of theta, and the tangent of theta. So let's take a look at this diagram. Oh, I forgot to actually draw the diagram yet again. And again, you don't have to do that on the test. That's just me and my brain. I'm a very step-by-step kind of guy. So 2 radical 65 is here. 18 is here. 8 is here. It's a right triangle. Don't forget that. Don't yell at me. So theta's there. Let's start making some trig functions. The sine of angle theta would be 8 over 18. The cosine of angle theta would be 2 radical 65 over 18. And the tangent would be 8 over 2 radical 65. All right, let's do the trig reciprocals. 18 over 8. 18 over 2 radical 65. And 2 radical 65 over 8. I am once again, if this is comfortable for you, feel free. You don't have to do anything more. I'm impressed. You're fantastic. You're awesome. You're amazing. But if you wanna get a little bit more advanced, go ahead and simplify the following fractions. If I can divide the top and bottom by 2, that'd be 4/9, therefore making the cosecant 9/4. 2 and 18 can simplify to become 1/9, so this becomes radical 65 over 9. 8 over 2 becomes 4 over 1, or 4 over 1 times the square root of 65. So these are the secant cotangent. My bad. The secant is 9 over radical 65. So the cotangent of theta would be radical 65 over 4. Either way, there you go. Hope you guys have a great day. We'll have one more review day tomorrow, and then I'll assign the test by sharing it as a Google Doc. You can print it out, handwrite it, and then scan it back to me, or you can type it, but I do want to see the work, okay? Have a great day.